Yeah,
How are you doing tonight?
I'm good. How are you?
Good. All right. So what do we got tonight?
Same worksheet as last time.
Let's see. You sent me the worksheet last time?
Yeah, that's what we were working on.
Yeah, let's see.
I could send it.
Well, I still have it. I just have to find it. When was our last session? Was it Wednesday?
On Wednesday.
This is the 22nd. So that would have been the 20th.
The 20th.
Let's see if I can find it here. Yeah, right here. It's just one sheet?
Yes.
Okay, how far did we get? I don't remember doing too many of these. I don't remember doing...
We got through.
Seems like we did E.
Hang on 1 minute. Alright, sorry, I'm back. I forgot I had a tutoring thing.
Okay, I seem to remember doing B.
Yeah, we got all the way down to the scientific notation.
Okay, all right. All right, and we did N. Don't think we did O. Let's start with O. What's 0.1 times 10 to the 0th?
That would just be 1 or 10.
What's 10 to the 0th equal to?
10.
No? 10 to the 1 is 10. Remember, anything to the 0th power is 1.
Oh, okay, I remember that now.
So that's equal to 0.1. All right, the next one. 5,342,000. How would I express that as scientific notation? What's the first thing I would do? Remember, the number has to be between 1 and 10.
So it would be 5.342.
Okay, times 10 to the what? Count the number.
6.
Count the number after the 5. How many spots are there?
6, so 10 to the 6?
Yeah. In other words, if I had the number, say, 5 million, we know that's going to be 5 times 10 to the 6th, right? Because there's exactly 10 0 or 6 0. Well, this is the same problem, only there's decimal. So we want to count how many numbers there are after the 5. And there's 6. Okay. Point 0602. What's the first number? What's the first thing going to be?
Move everything over.
Well, figure out what the first number has to be. The first number has to be between 1 and 10. So what does it have to be?
6.
6 what?
6.02.
Huh? So we know that much for sure. Now the question is, how many decimals do I have to move it over to get it to there?
2.
What should this be?
So 10 to the second power.
Well, not 10 to the second. 10 to the second would be 100. So that would end up being 602.
So it'd just be 1.
No, it'd be
10 to the
10 to the minus 2.
Mm.
In other words, when you have to move the decimal point 2 spots to the right, you have to reduce this.
Oh, okay.
Okay? Well, let's think about this. In other words, you can figure this out. 6.02 times 10 to the 1 would be what?
60.2.
Yeah. Times 10 to the 0 would be what?
60.2.
Well, 10 to the 0 is 1. So it'd be 6.02. You with me?
Yeah.
Okay. Times 10 to the minus 1. What would that be?
0.62. 602.
2. So times 10 to the minus 2, we just keep moving that decimal point 1 over. And that's what you'd get.
Okay.
Okay? All right. How about 2? The number 2. How do I express that in scientific notation?
2.0.
Okay. Actually, yeah, they do add the 0.0. Excuse me. Okay. Times 10.
And 10 to the first.
10 to the first would be what?
100. So it'd be 0.
No. 10 to the first would be 10.
Yeah.
2 times 10 would be 20. So it's got to be 10 to the 0. You see why?
Yeah.
In other words, we want to multiply this 2.0 times the number 1 to get the same thing that we started with. All right. So this one, they want our answer in both decimal and scientific notation. So the first one, the decimal is pretty easy. What's the decimal expression? Well, the way to do these is multiply the whole numbers, multiply the tens, and see what you start with. What's 9 times 4?
36.
What's 10 to the minus 4th times 10 to the minus 1?
1,000 to.
Well, let's express it in scientific notation first.
Okay.
In other words, it's easy to do in scientific notation, as all we have to do is add the exponents.
Mm-hmm.
What are those two exponents added together?
-5.
Correct. Okay. So that's the number. Now we have to figure out how to express that in decimal form and scientific notation. Well, the scientific notation means I have to move that decimal to the left because the decimal is right there at the moment. So when I have to move it to the left, what do I do with this exponent? Do I reduce it or increase it?
You reduce it.
Well, actually I increase it. In other words, we're making 36 3.6. So we're reducing the 36, which means we have to increase this, which means I increase it by 1.
Okay.
The way to figure this out is say we had 20 times 10 to the 0. What's that equal to?
20.
Okay. So if we want to express this in scientific notation, what would it be? What would it be? What would the 20 become?
Wouldn't it just be 20?
Remember, the first number has to be between 1 and 10.
So it'll be 2.0.
And now, what does that cause this exponent to have to be?
-1.
No. How do I get 20? In other words, 20 can't change. It's got to be equal to 20. So what would you multiply 2 by to be equal to 20?
10.
10 to the 1. The reason I show this is because you can always figure out what to do to the exponent depending on which way you move the decimal point. Which way did I have to move the decimal point in this case?
Back one.
Say left or right?
To the right one.
To the left. At the starting decimal point, hold on. Wow. The starting decimal point was right there, right? It was 20. So to change the 20 to 2, we had to move this decimal point to the left, one spot. So when we move the decimal point to the left, we increase the exponent. Now, I understand how that can get confusing and you can sometimes get it reversed. But that's why I illustrate this problem. It's because this problem will always tell you which way to move it relative. In other words, we know that 20 times 10 to the 0 is equal to 20. And we know that 2.0 times 10 to the 1 is equal to 20. So that gives us our rule on which way to move the decimal point and what to do with the exponent. Hold on one moment. I gotta open this up again. Okay. So, hold on. My tablet is not being cooperative here. Huh. Well, I'm going to have to do the rest of this with my mouse. It's okay. Let's write this number. If that's a number, then if I want to express that in some kind of scientific notation, what would it be? 10 to the what?
10 to the... yeah.
Okay, that's equal to 200, right? Where's the decimal point on the 200 over here? It's right there. Okay. So, if I want to express this in proper scientific notation, what do I have to do with that decimal point?
Move it to the right or to the left.
By how many spots?
2 spots?
Yeah, it's not just moving it right or left, it's how much. Okay, well, I have to move it to right there. I have to move it 2 spots to the left. And what do I have to do with the exponent on the 10?
Bring it up so it would be 10 to the first.
10 to the first is just 10.
Yeah.
Well, 10 times 2 is 20. It's not 200.
So it'd be 10 to the second.
There you go. In other words, you move the decimal point, or you move the exponent up by the same amount that you move the decimal point to the left. And these kind of problems will always answer. In other words, let's say that 6 months from now, you're trying to figure out, oh, do I move the exponent up or down? It's really easy to get them confused when you're going left or right. Well, use a case where you know the answer. We know the answer to this one. We know we have to move that decimal point left 2 spots, and we have to move the exponent up 2 spots. So that's the pattern. When you're moving the decimal point to the left, you move the exponent up. When you move the decimal point to the right, you move the exponent down. All right. How about number T? We have, oh, that's right, that's not working for some reason. Okay, so we have 5/8, right? Times 10 to the what?
-2.
Well, it's 10 to the -2 divided by 10 to the -6. What's that?
You'd be subtracting it instead of dividing it.
Subtract those two numbers. What do you get?
0 to the...
No, not 0. -2 minus 6.
That would be -8.
No.
Wait.
-2 minus a -6. What is that?
Four.
Okay.
+4.
All right. So that's our answer. Now they want it expressed in scientific notation, and they want it expressed as a decimal. Well, first of all, what's the decimal 5/8?
0.625.
Or how about just 0.625? We don't need the leading 0. Okay. So this is the next step. Now, how do I express that in scientific notation?
6.25 times.
Okay. Which way did you have to move the decimal point?
To the left.
Okay, the decimal point was there. It ended up there. Which way is that?
To the right one.
Okay, so this time we're moving it in the other direction. What do we have to do to the exponent?
Subtract.
Yeah, by exactly the same amount as we move the decimal point, 1 spot. So that's our answer. Now let's express it as a decimal. What number is, well, first of all, what's 10 to the third?
1,000.
Okay, so what's 6.25 times 1,000?
6,250.
Yeah. So what did we do with the decimal point in order to write it as a number?
Moved it to the right 3.
Yes, perfect. In other words, this is the same as times 10 to the 0. So we dropped, and you always want to do it times 10 to the 0 when you're converting it to a decimal, because you don't need to write the 10 to the 0. That's the final answer. And that's how you do scientific notation. If you move the decimal point to the right, you subtract from the exponent. If you move it to the left, you add to the exponent.
Okay.
number u, they have y equals 1/2 to the x power. Apologize for my handwriting. I'm going to have to reboot my computer to fix this, but I'll just wait until we're done. So they said make a table. Let's plug in some values for x and figure out what y is, and then we'll just graph that series of dots and connect the lines. So give me a first value for x.
2.
You know what a really good first value for x always is?
0.
Yeah, why? Because anything to the 0th power is what?
0.
No,
Or
it's 1. Any number raised to the 0 power is 1. In other words, I could take 10 to the 0, it's equal to 1. I could take 1,000,000 to the 0, it's equal to 1. I could take negative 1,000,000 to the 0, it's equal to 1. And in fact, I could take 0 to the 0 power and it's equal to 1. So the reason 0 is a good first number to try is you don't have to do any math. You know that the moment you plug in 0 for x, y is equal to 1. What's another good value for x? What's the next easiest thing to do?
1.
What's y when x is 1?
2.
What's 1/2 to the 1 power?
1/2.
Anything to the 1 power is the same thing.
Yeah.
So it's got to be 1/2. Right? In other words, when you raise something to the 1 power, it's just like you're not doing anything to it. 1/2 to the 1 power is 1/2. 1/10 to the 1 power is 1/10. 1,000,000 to the 1 power is 1,000,000. Okay. Next, let's try 2 for x. Now we have to do a little math. What's y when x is 2? In other words, what is 1/2 times 1/2?
That would be 1.
What's 1/2 times 1/2? Not plus.
Oh.
When you multiply two fractions, you multiply the numerators and you multiply the denominators.
One-fourth.
Okay. How about 3? When x is 3.
1/9.
1/2 times 1/2 times 1/2. 2 times 2 times 2 is what?
Oh, 1/8.
Okay. And we can see that as x goes up, y goes down. Let's try a negative exponent. Negative 1. What is 1/2 to the negative 1 power?
That's
Remember, negative exponents, what they mean is 1 over 1/2 to the positive 1 power. That's what that means. That's all a negative exponent means. Is the very first thing you should do is make it the reciprocal, 1 over 1/2. Okay? Let's just review that for a moment. What is 3 to the minus 2 power equal to? 1 over 3 squared. See how it works? In other words, a negative exponent, the way you express it is to just make it the reciprocal to a positive exponent. So 3 to the minus 2 power is merely 1 over 3 to the plus 2 power, which is 1/9. Okay? I'll give you another one. Make sure you get it. What is 4 to the minus 1?
1 over 4 to the first.
You got it. To the positive 1. We don't need to write it. So that's how you deal with negative exponents. Okay?
Mm-hmm.
All right. So in our case, we have 1/2 to the negative 1. Well, that's 1 over 1/2 to the positive 1. And what is that equal to? What is 1 divided by 1/2? How do we divide by fractions? You reciprocate the bottom and multiply.
Mm-hmm.
So that's equal to 1 times 2 over 1, which is equal to 2. So 1/2 to the negative 1 power is equal to 2. You with me?
Yeah.
I don't want to go on unless you understand this. Math is such that if you don't know how to do negative exponents, you're not going to know how to do any of this.
Mm-hmm.
So we have to get you to where you understand negative exponents. Okay? Now, we can graph that table. Let's graph it. In other words, if you don't know how to graph something, you can always make a table and just graph the points and then connect the dots. Well, if that's 1, let's not make that 1. Let's make that 1 up here. Make that 1. And we'll make that 1. So, how do I make the graph here? Given this table, and that's the x-axis, this is the y-axis. So where's my first dot go?
1 over 0. 1, 0.
Is it 1, 0 or is it 0, 1?
0, 1.
0, 1, exactly. In other words, you always give the first number as the x-coordinate.
Mm-hmm.
Where's the next dot go?
1, 1/2.
That's right there. The next dot?
2, 1/4.
Okay, we can see what's going on here. 3, 1/8. So we can see that this thing is asymptotic to the x-axis. It never quite reaches it, but it's always going to get closer. And then when I go -1, what is the y value?
2.
Which is up here.
Mm-hmm.
So the whole curve looks just like that. And it would keep going like that if I extended it. In other words, if I drew a bunch of dots. So it's good to know that you can always graph anything by making a table and connecting the dots.
Okay.
Okay? All right. It's 5:30. We didn't finish all of these. Maybe one more session, maybe a half a more session, we get to the rest of these. I will I
Yeah.
will leave it up to you and your mom if you want to schedule that. I got a lot of time tomorrow. I'm completely open tomorrow. I don't have much time on Sunday. Do you have a final coming up next week?
I need to check what my final schedule is because they're splitting our classes
Okay.
up, so.
Okay. Well, why don't you check when your final is and talk to your mom and tell her that we still have maybe a half hour worth of material to cover.
Okay.
And then you can try to schedule it whenever you can find time. This is what my next week looks like. It's fairly busy on Monday and Tuesday, and then it opens up completely. So if your final isn't until late next week, you got all the time in the world to schedule something.
Okay.
Okay? All right, Kendall. Good luck if I don't talk to you again, and if I do, I'll talk to you whenever that is.
All right. Thank
You're
you.
welcome. Bye bye.